Sorry. Dominique! Dominique, Catherine, Hannah, Zach, Anna, Kristen, Cody. I want everybody's attention up here, and I'm going to ask some questions, and I want to hear really good voices. I want some good energy. Can we practice? All right. How do you spell or say my last name?
Scamhorn.
Okay. That was really not a good try. Let's try it one more time with the enthusiasm and the voices I asked for.
Scamhorn.
There we go. It's a little bit better, but not completely. All right. So, you know, if we were really in a classroom together, I would have you doing this experiment. Unfortunately, this is not set up that way, and science is no way to be spent just looking at a board. And I'm sorry that we're doing that, but it's what we have to do, and it's the time frame we have to work with right now. So we're going to talk about chemical changes. What do we know about chemical changes? Does anybody in here know anything about chemical changes? Zach, nice and loud.
Changes one substance into another.
Okay, that's true. Can we turn that substance back into the other substance?
Yeah.
Yes.
Sometimes, but if it's a truly chemical change, what happens if we're frying an egg? Can you put that egg back into the yolk and back into the egg and seal it back up? No. So some things can be reversed, and that is true, but when you have a chemical change, more often than not, it's not going to be able to be reversed. You can't turn a burnt log back into a regular wooden log. It's just not going to happen. Now, from my understanding, we were supposed to talk about our the curriculum and that kind of thing, so I do have my objectives up here. Objectives are something that you all will be studying a lot more. I'm going into student teaching, so I have a little bit of an idea. It's actually will be pounded into your head that you want something measurable, you want to have an activity, and you want to have proof. So that's kind of why I have that up here, and just that I thought that we were all supposed to have that in our presentation. So what do we know about chemical changes? Well, first of all, this right here says it, doesn't it? Is anybody brave enough to say it out loud?
Okay.
So we know that when we have a chemical change, we're going to hear stuff sometimes. It's going to be fizzling. Has anybody ever seen Alka-Seltzer or the commercial? When you put that in the water, what's it doing? Pardon?
It fizzes.
It's fizzing, but why is it fizzing?
There's a chemical
change happening.
It's like it's dissolving, right? And there's some carbonate in there that's making it go bubble, bubble, bubble. A lot of times we'll have a smell. Now this is something that we're going to get into is when we talk about what kind of chemical reaction we have, whether it's a replacement, and that's when we're talking about the periodic element of charts and compounds. Temperature, that is really, really, really big with chemical changes because you're going to be talking about how much energy something takes to change from one form to another, to bond, to break that bond, and if it forms a new substance or not. And so, this is what I was asking about. Can somebody help me on if I can make this bigger because I could not make it bigger? Yes, Zach.
You just hit it and you can drag.
Yeah. There you go,
Yeah,
in the bottom circle.
There we go. Okay. Now, the gentleman who's narrating this, I don't think that was his day job. But if you can just bear with it, it's actually kind of interesting. But we're talking about flubber and how to make flubber.
We call flubber. First, in a plastic cup, pour a small amount of liquid starch. You can find this in the laundry section of most stores. In the second cup, pour an equal amount of white school glue.
One of the things I also want to do, I'm pausing this, I want you to look around. They're in a chemistry lab. So remember the first day when I had you sign those sheets, and on those sheets it said you were always going to be wearing your safety gear and that we would never be touching the chemicals with our hands. Keep an eye on what they're doing in this class, and then you can tell me what you think if they're following the safety guidelines that we spoke of.
Next, mix the two together by pouring the liquid starch into the cup containing the glue. If the mixture is too sticky, add more starch. If the mixture is too runny, add more glue. An easy way to color your flubber is to dab it with a marker. One last step, having hours of fun with your flubber. Be sure to store your flubber in a plastic sandwich bag so that you can enjoy it again and again.
So what is going on? The glue molecules and liquid starch molecules bonded to form flubber. The flubber you created was a polymer, and this is why it could stretch, break, and then rejoin as one unit. White school glue contains a polymer called polyvinyl alcohol. This polymer can be cross-linked by certain substances like liquid starch.
Okay. So what did you think about the atmosphere of the chemistry room? Catherine?
They weren't wearing their gloves, their goggles, or aprons.
Exactly. And somebody, towards the end, they were sitting on the desk and they had their shoes off. We always have the closed-toed shoes on when we're in the chemistry lab. Now, as a good chemistry teacher and also somebody who likes to have fun, I know that taking borax or starch and mixing it with glue, you're not going to have any kind of toxicity that's going to burn your fingers, and I would let you play with it. Towards the end of the video, what they showed were the long polymer chains, and that's in all plastics and any kind of plastic. And actually, in the next picture, well, darn.
Oh, you have an activity on that one?
Yes, I do.
All right, go ahead and exit your screen.
Exit, right here.
The screen box, see the blue screen?
Oh,
Tap that. And then go to the activity builder on the left-hand column. You're going to have to hide the toolbox. Okay.
this right here?
Yep. Click on an image. Click on another one. One of those has a... Oh, try activity builder there. Click on that. Click reset.
Okay.
Is that all of them? Do you have
Yeah.
more images?
No, that's it right there.
Okay. And then just go back and up on top to quick view.
Thank you. Okay. It came up when I tested it in one of the other rooms. So, anyways, when you have Jell-O, you're actually eating polymer strands. Those chains of stretchy stuff. Are you glad to know that now? So I need somebody. Cody, what about you? I don't know that I've seen you come up here. I want you to tell me, right here we have PVC piping. That's a really stiff, rigid polymer. And down here we have Jell-O, which jiggles. Can you come up here and tell me which polymer strands would match which one? You can just drag one to the other. Yes, exactly. Because the really, really rigid ones are going to have tight notched, very, very, very pushed together strands, and then the Jell-O is going to have nice, loose, wiggly, waggly. So, does anybody have any questions? No questions?
Instead of borax, can we use Jell-O to make great tasting flubber?
No, you really need to have the starch. Actually, because Jell-O in itself already has the mixture together. But if there are no questions, then thank you very much for your participation, and I appreciate it. Thank you, Dominique, for taking that.